Okay, good afternoon, all of you. Welcome to this lecture of refrigeration and air conditioning. So today we'll start our fourth chapter. Okay, so I have spent enough time in practicing our numericals of first chapter. Then I took one presentation related to Ministry of Food Processing Industry. Last lecture we calculated what are the heat loads acting on a cold room. So I have elaborated that problem that we are using this cold room for storing the apples. Then I have given you the load that I am putting 4 tons of apple per day in that cold room. And then we have considered other factors also like fan, evaporator, defrosting, lighting, people, all those heat loads we have considered, and then we calculated our value. Then at the end, we assume one safety factor of 20%, then 20% more of that load value. That is what we call it as a design load. So almost like 6 ton, not 6 ton, 6 kilowatt, what we got as a total heat load. Okay. Accordingly, then next step will be like selection of equipments, selection of this refrigeration systems and its equipments. Then all this construction and assembly of these equipment. So that will be next stage in that. After that, there will be sales. So whole this process works like this. So I hope you may have read about this product life cycle. So whenever we decide to go for production of a component, so it starts from ideation phase. So there is an ideation phase, then there is a prototyping phase. The company creates one prototype. So if you go for automobile industries, they create a prototype of a mold, okay, sand clay. From that they prepare one prototype. If that prototype is accepted by the design team or the higher authorities or executives, then that goes into the production. So prototyping, and after prototyping, it is decided that whether should we accept or whether should we reject that component. After it has been accepted, then it goes to further detailing of that product. So detailing means we go for the CAD drawing, then goes for a computer aided manufacturing. After that, the products are manufactured in assembly line. They are assembled. One final product is produced, and then it is packed. So then comes the job of marketing and sales people, and then that product is dispatched. It is delivered to the customers. Then there comes a job of after sales. So after sales is another team. It is there. It is not very popular in our Indian culture, Indian industrial culture, but it is there in Germany. If you go for European countries, so one of my friend, he has completed his MS in automobile industry, but related to after sales. So whenever they sold their vehicles, 4 wheelers, after that comes the job of this after sales people. So they go for this regular maintenance, and whole the economy is very big involved in that after sales. So this is how this product life cycle works. So you can Google it, product life cycle. You will get the idea. Okay. So coming to our today's presentation, today we'll start our fourth chapter. Our fourth chapter is vapor absorption systems. So in chapter 1, we have studied vapor compression system. So as the name suggests, there is a vapor of refrigerant. Compression means it is compressed, and then there is a system, vapor compression system. Now in this chapter also, this title suggests us something. So there is vapor of refrigerant. Absorption means there is a mixing of refrigerant with the solvent. So that solvent will absorb the refrigerant. That is why this term is there, absorption. And there is a refrigeration system. So there are two systems majorly involved. One is VCRS, that is vapor compression refrigeration system. And another is this one, VARS, vapor absorption refrigeration system. Okay, so whenever you study refrigeration system, these two things will come, VCRS and VARS. So this is the syllabus. It will start with the introduction, and then we'll see what is the simple vapor absorption system. And that will take example of ammonia and water. So ammonia is, you know that it is a refrigerant, and water is, in this case, it will be solvent or it will be a absorber. Then a practical ammonia water vapor absorption system, comparison between vapor absorption and vapor compression system. Then we'll see one derivation, small derivation is there for the COP of ideal vapor absorption system. Electrolux refrigerator, lithium bromide absorption system. Okay, so this Electrolux refrigerator, it was very famous in back and 1970s. Okay, so see here, the thing is, this system, VARS system, is a way older than the VCRS system. Okay, even before this vapor compression system was invented, before that people were using this vapor absorption refrigeration system. But what happened, this chemical industry, they invented various refrigerants that can work for very low temperatures. Okay, then there was advancement of compressors. So with these two major research were made in compressors and refrigerants, vapor compression and refrigerant system were very popular. But as this cost of compressor were increased, and this some of the refrigerant that we have studied in chapter number 3, that CFCs, chlorofluorocarbon, they have this ozone depletion potential and global warming potential, they were phased out. So after that, this vapor absorption system again became popular. Okay, so it started with VARS, then VCRS took its place, it became famous, but because of this ozone depletion and global warming, slowly people started again using VARS system. So this is the history behind it. Then last is new mixtures for vapor absorption system. Okay. Okay, noted down. We'll see. So we'll start with our revision. We'll take a quick revision of our first chapter, where we have studied vapor compression refrigeration cycle. So I will also revise some of the concept. So we started the whole this subject with analogy to the water pumping. Okay, so if I want to take water from a lower level to higher level, from ground to our terrace, in that case, what we have to do, I have to use external work. Okay, because water naturally flows from higher altitude to lower altitude. But if I want to reverse its direction from lower altitude to higher altitude, I need an external work. So same analogy I can use in case of refrigeration system. So naturally heat flows from higher temperature to lower temperature. If I want to reverse it from lower temperature to higher temperature, so in that case I will need an external work. Okay. So after that we saw Valley-Coleman cycle, which was ideal for air refrigeration system, and then we have seen vapor compression refrigeration cycle. So we all know that in this cycle there are four major components. First is a compressor, then condenser, then expansion valve, and evaporator. So evaporator is what extract the heat. It is the component which fulfills our objective. So our objective is to extract the heat from the lower temperature. So evaporator is the component that will fulfill our objective. Okay. So most common refrigeration cycle is in use today. There are four principal control volumes involving these components. So control volumes and there is control mass. So control mass is related to closed systems, and control volume is related to this steady flow systems. Okay. So major components here, there are evaporator, then next is compressor, condenser, and expansion valve. All energy transfer by work and heat are taken as positive in direction of arrows on the schematic, and energy balances are written accordingly. So here in this case, evaporator will take a heat from a lower temperature reservoir. Then that refrigerant, it will be superheated or it will be dry saturated. So it will be passed to the compressor. Now, function of compressor is to increase its pressure, so it will be compressed to a higher pressure. So as the pressure increases, its temperature will also increase. Then it will be passed to the condenser. In condenser, it will release some of the latent heat. So ideally, if I go for VCRS system, it should take in here latent heat, and here it should release a latent heat. Okay. So condenser and evaporator, they are set to work at constant pressure and constant temperature. So leaving the condenser, there is a high pressure and a low energy liquid, so which will pass through the expansion valve where it will be converted into vapor. So at the entry evaporator, we have a mixture of liquid and vapor refrigerant. So again, that cycle will repeat itself. Okay. So this was all related to VCRS system. So what happened here? What are the limitations in this case? So here we are using a refrigerant. So refrigerant is a heat carrying medium. Now, initially they were using the CFCs. So CFCs, chlorofluorocarbons, and because of their ozone depletion potential as well as their global warming potential, they were phased out. So that was first problem, and second problem was this compressor. So compressor means there will be some moving parts, so there will be vibrations and there will be use of electrical energy. So if I want to use a VCRS system, I have to depend on external source of energy. I have to depend on local grid connection. So in our case, it is a MSCB. जर मला एक VCRS सिस्टम चालवायचं असेल तर ऑब्व्हियसली मला इलेक्ट्रिक सप्लाय लागणार आहे. आता इलेक्ट्रिक सप्लाय कुणाकडून मिळतो तर MSCB कडून. So I have to depend on others. Okay, so I have to depend on others to run my own system. So there was this gap, technical gap in this system. So if I'm designing my system, why should I depend on others? Okay, so what happens in vapor absorption system? This compressor is been replaced by absorber and generator. So in that case, what happens? We are using energy from either from solar energy, or we are using the energy by burning fossil fuels, or we are using that waste heat from industry or from the space which is coming out. So in that case, we have ready energy in our hand. If I am using solar energy, so it is available in abundant amount. So I will take the solar energy and I will give it to the generator. So in that case, this dependency on grid connection is being eliminated. Okay. So what is that VRS system? That we'll see in next slides. Okay. So vapor absorption refrigerant system. This is his just introduction. So I'll read it. So an absorption refrigerator is a refrigerator that uses a heat source. So for example, solar energy, a fossil fuel flame, waste heat from factories or district heating system to provide the energy needed for the cooling process. So in case of VCRS, we need electrical energy. In case of vapor absorption, we can take it from either from solar, we can take it from fossil fuels, we can take it from waste heat. Okay. In this system, mechanical compression process of vapor compression cycle is replaced by a thermal compression process. So what is this? We'll see in next slides. So this thermal compression is achieved by following processes. So first, it is absorbing a fluid vapor. So see, in this case, in this VARS system, vapor absorption refrigeration system, there is one concept involved, that is absorption. Okay, so we need one solute and one solvent. Okay, so we need a refrigerant and we need a absorber. So if I take an example of ammonia water system, which is generally called as aqua ammonia, so in that case, ammonia is our refrigerant. Okay, and water is our absorbent. Okay, now water being an absorbent, it has tendency to absorb the ammonia. Now there is a concept of temperature involved in it. So lower the temperature of water, greater will be its affinity to absorb the ammonia. Higher will be the temperature of water, lesser will be the affinity to absorb the ammonia. So in that case, we have to maintain the temperature of water very low in order to absorb more and more ammonia. So that is our first point, absorbing a fluid vapor. Now second is pumping the solution to high pressure cycle by a simple pump. So in this case, pump is involved. In VCRS, compressor is involved. So in this case, pump is involved. Producing vapors from the solution by heating. So for this purpose, we are using a generator. आता ते जनरेटरला तर तुम्ही हीट कशी देऊ शकता, सोलारची देऊ शकता किंवा फॉसिल फ्युएलची देऊ शकता किंवा तुम्ही स्टीमद्वारे देखील देऊ शकता किंवा एक इलेक्ट्रिकल हीटर वापरू शकता. But our objective is to not to use electrical. So in that case, I will use a steam tubes. So that in that generator, heat is supplied and this ammonia is separated from water. So our objective to carry out the absorption process is to create a mixture of water and ammonia. This mixture is pumped so that pressure is increased and then it is passed to generator. In generator, this ammonia is separated from water. This ammonia vapors will be passed to the further process. Further process means there will be condenser, then there will be expansion valve, then finally there will be a evaporator. So what is this process? We'll see. Okay, so before going to actual explanation of this VRS system, first we'll understand where these systems are used. So where vapor absorption refrigeration system is used. So first, electricity is unreliable or load shedding is very frequent. So we don't want to depend on local electrical board. Then the places where noise from the compressor can be create disturbances. In VRS, there is no compressor, so very less noise. So compressor also we have to exclude from our system. Next is where extra or exhaust heat is easily available. So where this waste heat or solar energy or fossil fuel heat is easily available. For example, the surplus heat from the power plants can be used or solar energy can be used. So the surplus heat from the power plants means from the boilers. So a lot of energy is wasted in boilers. So that waste heat we can utilize for our VRS system or solar energy. So we being at this Mediterranean level, आपण एक विषुववृत्त असल्यामुळे आपल्याला एक advantage आहे की so we have abundant amount of solar energy. Okay, so if I compare our solar radiation with solar radiation in Netherlands, so they have very less solar radiation. So we have that advantage. But still, Netherlands is very advanced in agriculture. So you can watch on Google or you can watch the videos on YouTube how Netherlands has become the agri experts. So even though their solar radiation is very less, their land is very less, still they are largest exporters of these tomatoes and that's Shimla mirchis. Okay, so that depends on the technology. So wherever that extra heat is available, there we can use this VRS system. Okay, so we'll see what are the basic principles. So basic principles of vapor absorption refrigeration system. We'll see what are the components involved in a simple VRS system. So first we'll see a simple, then we'll see a practical example or practical VRS system. The compressor is replaced by a generator, a pump, and an absorber. So the basic components of a vapor absorption refrigeration cycle are: the first is generator. Okay, generator means we are supplying external heat to it, and its only objective is to increase the temperature. The second is pumps. Pump, we know these are used for only fluids. Fluids, that means liquids. So we cannot use a compressor for liquid. So there is a difference between pump and compressor. Pump can be used for only liquids. Compressors can be used for only gases. Third is absorber. So we need a like closed system or closed box where this refrigerant and this absorbent they can be mixed together. Then there's these are the regular components, that is a condenser, then there is evaporator, and there is a expander or a throttling device. So these are common from our previous VCRS system. Addition here it is a generator, pump, and absorber. 7 and some other components like rectifier, analyzer, and heat exchanger. So what are these? These are involved in practical VRS system, but first we'll see what is a simple VRS system. So in today's lecture, we'll see this simple VRS system, and we'll also see what are the differences between VRS and VCRS. Next lecture, we'll take that COP derivation. Okay. So this is the diagram for the simple vapor absorption system. So see here, I will explain step by step. First, we'll see what are the components here on the screen. So this is the evaporator. So we all know that evaporator is the component which extract the heat from a low temperature reservoir. So in this case, we have used ammonia as a refrigerant and water as a absorber. Okay, why we have used water? So it is a property of water that it has the largest affinity to absorb the ammonia. So for that purpose only we are using a water. So we know that evaporator, what does the evaporator do? It takes the latent heat from the space. In that case, whatever liquid or the liquid vapor refrigerant it is there. In this case, ammonia is there. It is converted into vapor or superheated ammonia. So this vapor ammonia, low pressure ammonia vapor, it is passed to the absorber. Okay. So this ammonia, see, it is in the vapor form, and water inside the absorber, it is in the liquid form. But because of water's affinity to absorb the ammonia, this liquid water will absorb the vapor ammonia. Okay. So these ammonia vapors are passed to the absorber. In this case, water is there. So liquid water will absorb the vapor ammonia, and this absorption will take place. So this absorption process, त्या केस मध्ये liquid water vapor ammonia absorb करतात. ती process मध्ये काय होत असतं तर it is an exothermic reaction. So in that case, some heat is being rejected and the temperature increases. So in order to reduce that temperature, here we are using a cooling coils. Okay. See, I will repeat again. This absorption process is an exothermic reaction. So in that reaction, what happens? The temperature increases. So as the temperature increases, water's affinity to absorb the ammonia vapors reduces. म्हणजे water जास्त ammonia vapor absorb करत नाही जसं temperature वाढतं तसं. So our objective is to lower the temperature. So how to lower the temperature? So we are using the cooling coils. So in that cooling coils, cooling water flows, and that cooling water take the extra heat. So temperature is being maintained inside a absorber. Now next comes out as a strong solution. So whenever this ammonia and water, these are mixed together and concentration of water is more, so we calling that it as a strong solution. Okay. So this strong solution of ammonia and water, in general it is also called as aqua ammonia. So this strong solution of aqua ammonia, it is passed to the pump. Now we are at the pump. So pump will increase the pressure of this mixture. So in that case, what will happen? This high pressure aqua ammonia mixture, it will pass to the generator. Okay. Now we are at a generator. So generator, so this is not our diesel generator. This generator means we are giving some external heat to it. So in this case, they have again used these heating coils. In this coils, I will pass steam. Okay. So steam or heating coil, it will be used to transfer the heat to the generator. So what is happening? We are increasing the temperature by passing the heat to the generator. In this case, what will happen? This strong solution of aqua ammonia. So because of their differences in boiling point. आता कसं असतं तर अमोनिया रेफ्रिजरंट आहे तर आपण बघितलं की रेफ्रिजरंटचा बॉइलिंग पॉईंट नेहमी कमी असतो आणि वॉटरचा बॉइलिंग पॉईंट जास्त असतो. सो या केस मध्ये काय होणार आहे? जसं मी हीट देणार आहे. So as I give more heat, in that case, the substance which is having lower boiling point, so that will evaporate first. ज्याचा boiling point कमी आहे तो पहिल्यांदा evaporate होईल, ज्याचा जास्त आहे तो नंतर evaporate होईल. So in this case, ammonia is having low boiling point, so it will be converted into vapor. So this vapor ammonia, high pressure ammonia vapor, it will pass to the condenser, and whatever remaining ammonia and water solution is there. So the thing is here we cannot 100% separate ammonia and water. So even if I separate ammonia vapor, there will be some amount of ammonia present in the water. So whatever the solution coming out of generator here, we are calling it as a weak solution because it is having a less percentage of ammonia. Okay. So if I talk about a generator, generatorच्या एंट्रीला स्ट्रॉंग सोल्युशन आहे अमोनिया प्लस वॉटरचं. जनरेटर मध्ये हीट दिली जाते त्यामुळे काय होतं अमोनिया वेपर बाहेर पडतात ते जातात कंडेन्सरला आणि राहिलेलं जे सोल्युशन आहे ज्याच्यामध्ये अमोनियाचं पर्सेंटेज कमी आहे त्यामुळे आपण त्याला म्हणतो की weak solution. So that weak solution is passed to the pressure reducing valve. Okay. Now after it is coming to the pressure reducing valve, it is passed to the absorber again. So this weak solution is passed to absorber. It will take the ammonia vapor, then again it will become a strong solution. So if you see the cycle of this absorber, in this case it is a water. Its cycle is absorber, pump, then generator, then pressure reducing valve, and then again absorber. This is the cycle of absorber. But if I see the cycle of refrigerant cycle is evaporator, it will come to the absorber, it will go to the pump, generator, then it will go to the condenser. So in condenser, we all know that heat is being rejected to the atmosphere. So heat is rejected at constant pressure and constant temperature. So in this case, they have used a cooling water. So this condenser, as I showed you in one of my lectures, it can be air cooled or water cooled. So in this case, it is a water cooled condenser. Heat is rejected. Okay. So exit of condenser is a liquid ammonia. This liquid ammonia is passed to the receiver. Okay. It will receive the liquid ammonia only. Then liquid ammonia is passed through the expansion valve. We know the function of expansion valve. So expansion takes place at a constant enthalpy. So that is an isenthalpic expansion. So pressure is being reduced, and this liquid plus vapor ammonia is passed to the evaporator. So this is the cycle of refrigerant. Okay. And this is the cycle of absorber, from absorber to pump to generator to pressure reducing valve to again absorber. So in VRS system, there are two cycles involved. If I talk about the absorber, in this case, absorber is water. Its cycle will be only absorber to pump, pump to generator, generator to pressure reducing valve, then again to absorber. If I talk about refrigerant cycle, so refrigerant cycle will be evaporator, absorber, pump, generator, then condenser, then receiver, then expansion valve, and then evaporator. So there are two cycles involved in it. Okay. So I have a question here. Rohit says, sir, how the ammonia has high pressure after the generator? So for this purpose, see here we have used a pump. So pump's purpose is to increase the pressure of the liquid. So for that purpose, we are using a pump. So this is how we have replaced the compressor from a VCRS system. In VCRS system, we were using compressor to increase the pressure. In case of VRS system, we are using the pump. So if I talk about the pressure, so आपल्याला काय असतं, इव्हॅपोरेटर प्रेशर एक असतं, ठीक आहे. त्यानंतर ऍब्सॉर्बर मध्ये नंतर काय होतं, प्रेशर ड्रॉप होतं. सो दिस इज द प्रोसेस ऑफ ऍब्सॉर्प्शन टेक्स प्लेस. ज्यावेळेस ऍब्सॉर्प्शन होत असतं त्यामध्ये प्रेशर ड्रॉप होत असतं आणि टेम्परेचर वाढत असते. Okay, then that pressure drop, it is compensated with the help of pump. It is passed to generator. Generator is like a constant pressure heat addition process. Then it is passed to the condenser. Okay. So answer to your question is we are using pump to increase the pressure. Right. So any doubts? So I'll repeat this process again. See here, we are in basic vapor absorption refrigeration system. This system is way older than VCRS system, but as this because of ozone depletion and global warming, some refrigerants were phased out, and these compressors, they involve moving parts, so they are very bulky and they create noise. Also, they create vibrations. So considering these limitations, people are now switching to VRS system, vapor absorption refrigeration system. So we are replacing the compressor of a VCRS system by generator, pump, and absorber. हे पहिले तीन जे component आहे, generator, pump, and absorber, they are replacing the compressor part of VCRS system. Then we have condenser, which is common in both, evaporator, which is common in both, expander or throttling valve, which is a common in both. Then there are some auxiliaries, which are rectifier, analyzer, and heat exchanger. So these are related to only practical VRS system. Okay. Then this was the diagram for it. So in this case, compressor is replaced by absorber, pump, and generator. Okay. So compressor part of VCRS is replaced by absorber, pump, and generator. all this right part, that is the evaporator, expansion wall, and cooling, sorry, condenser, that is same. That is common in both VCRS and VARS. But this compressor is replaced by this part. Okay. So same as VCRS, the condition of refrigerant leaving the evaporator. The evaporator मध्ये काय होत असते तर ते heat absorb करत असते. So because of heat absorption, that liquid ammonia will convert into vapor ammonia. It may be dry saturated, it may be superheated. So that ammonia vapor is passed to the absorber. Now this gaseous ammonia is absorbed by liquid water. So there is this mixture is being formed. So that mixture we are calling it as a strong solution. So whenever I say strong solution, that means it has more percentage of ammonia. This solution is passed through the pump. Pump's function is to increase the pressure of the liquid mixture. So this mixture, strong mixture or strong solution, it is passed to the generator. Generatorचं function असतं की separate करायचे. So function of generator is to separate ammonia from the water. So in that case, we are supplying heat. So as the temperature increases because of differences in boiling point, अमोनियाचा boiling point कमी आहे, वॉटरचा boiling point जास्त असते. त्यामुळे आपण ज्यावेळेस हीट करतो जनरेटरमध्ये, त्यामुळे ज्याचा बॉइलिंग पॉईंट कमी आहे तो पहिल्यांदा वेपराइज होणार, राईट. सो फॉर एक्झाम्पल वी नो दॅट boiling point of water is 100, so and suppose boiling point of ammonia is 50, so I'm just giving a number. आणि जर माझं सोल्युशन आहे 30°C आणि मी जर ते सोल्युशन हिट केलं, आता 30चं 40 झालं, 40चं 50 झालं, ज्यावेळेस ते सोल्युशन 50°ला येईल तर काय होणार त्या केसमध्ये, अमोनियाचं बॉइलिंग पॉईंट आहे 50°C, so that will be evaporated. Then if I again increase the temperature, it will go to the 100. At the 100°C, again water will be evaporated. So whichever having the lower boiling point, that will be first evaporated in the generator. So in generator, ammonia vapor is separated. This ammonia vapor is passed to the condenser. Then that remaining process takes place. So in this case, it will release its heat to the water or the atmosphere. Liquid ammonia will get out of the condenser. Liquid ammonia, it is stored in the receiver. Okay. Then it is passed the expansion wall. Expansion wall आपल्याला माहिती आहे, isenthalpic expansion takes place. So its pressure is reduced. So here we have a liquid plus vapor ammonia. It is passed through the evaporator. So evaporator function is to extract the heat from the low temperature reservoir. So this way this cycle completes. Okay. So if you understood, please draw the diagram. So if anybody is having doubt, you can ask. So one more question by Rohit. This system used for only ammonia or others also? So here only for example purpose, I have taken ammonia and water. There is other system which is called as lithium bromide system, that also we'll study. Then there is another system which is called as Electrolux system, that also we'll study. So there are different mixture combinations are there. We have one point in our syllabus, which is the last point, that is the new mixtures for this VRS system. When that point will come, that time I will explain you what are the mixtures that are commercially used. This mixture is also very popular, aqua ammonia. So ammonia, it is not a dangerous gas, and aqua ammonia mixture, it also not non-explosive, non-toxic solution. That is why it is also popular. But apart from aqua ammonia, people are also using lithium bromide and water solution. Okay, so please draw the diagram. This diagram is very important. So in practical VRS system, only this rectifier will be added here. Then there will be one analyzer, and here there will be one heat exchanger. So there will be no much difference in between simple VRS system and practical VRS system. In practical, only rectifier, analyzer, and heat exchanger will be involved. Okay, I will give some time to draw this diagram. Okay, so I think I have one more question here. How absorber work? See, in this diagram, though it is showed with the help of a line that one line is connecting evaporator and absorber, but this is not the case. त्यामध्ये कसं असतं की डायरेक्टली हे जे आहे इव्हॅपोरेटर चं प्रेशर आणि ऍब्सॉर्बर प्रेशर ह्याचा सगळा खेळ आहे. तर ऍब्सॉर्बरचं तुम्हाला जर एक्सप्लेनेशन द्यायचं झालं, सो आय विल गिव्ह यू वेट. So see here, the thing is, there is one condition it is given. Okay, so I have water in vessel A here, and I have a lithium bromide solution at 30 degrees Celsius, 50% means 50% lithium bromide, 50% water, which is here in another vessel. Now these are connected with each other with the help of pipe, and there is one junction. This junction is now closed. So see here, water at 30 degrees Celsius, it has some saturation pressure, which is given at 4.24. This is a gauge pressure. Okay, this is not absolute pressure. This is a gauge pressure. It is its saturation pressure. If I take for lithium bromide solution, in this case, 1.22 kilopascal is its saturation pressure. So you can see there is a difference in pressures. Okay. पण या केसमध्ये वॉल क्लोज आहे, कोणताही मास ट्रान्सफर किंवा हीट ट्रान्सफर या केसमध्ये होणार नाहीये. आता आपल्याकडे बघा सेकंड केस आहे. या केसमध्ये तर कसं आहे की ह्यामध्ये मी वॉल ओपन केलंय. आता वॉल ओपन केल्यानंतर काय होणार आहे, हाय प्रेशर कडून लो प्रेशर कडे वेपर्स पास होणार आहेत. ओके, सो वी नो दॅट फ्लुइड पासेस फ्रॉम हाय प्रेशर टू लो प्रेशर. या केसमध्ये काय होणार आहे की ग्रॅज्युअली वॉटरचं हे जे प्रेशर आहे ते रिड्यूस होत जाणार आहे आणि त्यामुळे काय होणार आहे की वॉटरचे वेपर्स फॉर्म होणार आहेत. Okay, so this is a whole different concept which is called as vapor pressure. You might have studied that Dalton's law of partial pressure. In that case, we have studied that if I take pressure, it is a cumulative of individual vapor pressure. ठीक आहे, जसं की हवेत एअर आहे, वॉटर वेपर आहे, म्हणजे हवेचं जर मी प्रेशर घेतलं, इट इज अ ऍडिशन ऑफ वेपर प्रेशर ऑफ एअर अँड वेपर प्रेशर ऑफ वॉटर मॉइश्चर. ओके, so that is a Dalton law of partial pressure that we'll study in the second section. So in that case, this vapor pressure of water becomes low. Water vapors are being now transmitted to the from A to B. ठीक आहे, तर ह्या केसमध्ये कसं होणार की कंटिन्युअसली वॉटरचे वेपर ए तून बी मध्ये ट्रान्सफर होणार. सो देर इज अ मास ट्रान्सफर टेक्स प्लेस. As well as what happens, this temperature of water reduces because its vapor pressure also reduces. Okay, so previously its saturation pressure was 4.24. When I open this switch and I have maintained these conditions here. Okay, ह्यातल्या कंडिशन्स मी आर्टिफिशियली मेंटेन करणार आहे. ह्यातलं जे टेम्परेचर आहे 30 डिग्री सेल्सिअस 50% हे मी कंटिन्युअसली मेंटेन करणार आहे. त्यामुळे काय होणार आहे की टू अचीव द प्रेशर इक्विलिब्रियम ह्या जर 1.22 असेल तर ह्यामध्ये देखील 1.22 होणार आहे. टू अचीव द 1.22 kilopascal in vessel A, some water vapors will transmit from this A to B. So this is a concept of mass transfer. So it will try to go for saturation phase, पण त्यामध्ये काय होणार आहे, ह्याच्यातलं वॉटर कंटेंट कमी होणार आहे आणि ह्याचं टेम्परेचर कमी होणार आहे. ओके, तर ही सिस्टीम मध्ये आपण डायरेक्टली ए चा यूज ऍज अ इव्हॅपोरेटर करू शकतो. काय झालंय तर ए चं टेम्परेचर कमी झालंय, वी कॅन यूज इट ऍज अ इव्हॅपोरेटर. But what happens as continuously water vapors are going from this vessel to vessel B, थोड्या वेळाने त्यात इनबॅलन्स होणार आहे. ठीक आहे, मग तुम्हाला ही सिस्टीम बंद करावं लागेल, परत त्यात तुम्हाला ए मध्ये पाणी टाकावं लागेल, ह्यातलं पाणी त्यातून काढावं लागेल आणि मग परत तुम्हाला सिस्टीम चालू करावं लागेल. सो देर वॉज दिस लिमिटेशन्स टू दिस सिस्टीम. सो व्हॉट दे हॅव डन, दे हॅव कनेक्टेड दिस सिस्टीम इन आवर व्हीसीआर सिस्टीम. मग त्यातला आपण कॉम्प्रेसर रिप्लेस करून त्या जागी ऍब्सॉर्बर सिस्टीम हे टाकले. So this whole we can consider as a absorber. Okay, आपल्या त्या मगाच्या डायग्राम मध्ये जरी ब्लॉक दिसत असतं ना, तर त्या ब्लॉकच्या आतमध्ये अशी काहीतरी सिस्टीम असते. ओके, सो इट इज ऑल द गेम ऑफ वेपर प्रेशर. जो वेपर प्रेशर कमी झाला की टेम्परेचर कमी होत आहे. वॉटर वेपर ट्रान्समिट्स फ्रॉम वन वेसल टू अनदर वेसल. ओके, what is the vapor pressure? All that concept will be cleared in our second section, because our whole that calculations of heat load and the psychrometric chart that is dependent on vapor pressures. Okay, so I think that's it for today. Next lecture I will again revise this concept of vapor absorption. I will again explain some minute details. We'll see what is a practical VRS system. Then we'll see what are the differences between VCRS and VRS system. Okay. So meanwhile, you can Google what is the concept of vapor pressure. त्यापेक्षा सिंपल असंच करा तुम्ही ह्याचा शोध लावा की तुमच्या डेऱ्यातलं जे पाणी असतं, ठीक आहे, आपण उन्हाळ्यामध्ये डेऱ्यामध्ये पाणी ठेवतो आणि ते थंड होतं, तर ते का होतं ह्याचा एक तुम्ही शोध घ्या. त्यामध्ये देखील हा कन्सेप्ट आहे. This concept of vapor pressure and surface adsorption. Okay, so you go through that concept. You can go through simple examples. जसं की डो फॉर्मेशन का होतं ज्यावेळेस थंडीमध्येच दव पडतात, ठीक आहे. हे जे साधे साधे एक्झाम्पल आहे त्याचा तुम्ही शोध घ्या गुगलवर. यू विल अंडरस्टँड दिस कन्सेप्ट ऑफ वेपर प्रेशर. ओके, एनिवे वी आर गोइंग टू टेक दॅट इन सेकंड सेक्शन. But if you are really curious, then you can search how this water in that मडक्याचं आपलं काय म्हणतात डेऱ्यामध्ये वॉटर कसं थंड होतं किंवा ड्यू फॉर्मेशन कसं होतं हे तुम्ही सर्च करू शकता. ठीक आहे. So quickly I will take the attendance. I will not hamper you guys with more and more information.